Hi, everybody. Welcome back. Today we are going to get into chapter 24, section D1. We're going to talk about quantiles, or what's also called as k-values, with our normal distribution. So we've been looking at finding how far away a particular value is from the mean, right? How many standard deviations away, and we're looking based on given an x value, how far away that is from the mean to the left or to the right, or how much is below or above that particular value. What about the reverse? Let's look at an example here. This is kind of a fun example because it deals with crabs biting people. It says, consider a population of crabs where the length of a shell is normally distributed with a mean of 70 and a standard deviation of 10. And the biologist wants to protect so that only the largest 5% of the crabs would be harvested. So he wanted to know 95% of the crabs have lengths less than what? So what we're looking for in this example here is what's the probability that that x is less than some k value, where that probability is going to be 95%. So the area under the curve is 95, but we don't know what that particular x value is. They call it k here in this case, but where on that x-axis that line is going to be to give us that 95% probability cutoff rate. So those k values, that's known as what's called a quantile. And in this case, it's the 95th percent quantile. And that's what we're going to be talking about today. What's great is that your calculator does this for you, and we are going to be talking about instructions on the TI-85 or TI-84. And if you have that, go ahead and hit pause and get it. Also, the online normal distribution calculator that I've posted the past 2 weeks, that will also do this exact same feature. So because if you remember online, you had to put in 3 of the 4 boxes. We're just going to be putting values in a different box on that same website. So I'm going to give you the instructions on the TI-84, and then if you have any questions about it, let me know. So here is given a value where x is normally distributed as a mean of 23.6, right? So we know that's my mean. And then my standard deviation of 3.1, because that's standard deviation squared, that's the variance. And we want to find k for where the probability of x being less than k is 95%. So we want to look at to see what that value of k is going to be. So what we're going to use for this on the TI-84 is we're going to then do our second distribution and then go down to option 3, which is INV norm, which is inverse normal distribution property. And we press that, and we're going to have those 4 lines or 4 entry boxes that you see there. So for this particular one, we're going to say that our area, because we already know the area is 0.95. So I'll say that's 0.95. What's my mean? My mean is 23.6, and my standard deviation is 3.1. And let me put those into my calculator, 23.6 and 3.1. And then you go down to paste and hit enter, and you should get a k value, which again, this is the if you think of it as a z-score, right? It's that value, or sorry, sorry, not the z-score. It's the x value where everything to the left of that is going to be 95% underneath the curve, and this value is going to be, I get a k of 28.7 approximately. And that's what my k value is. And here's a good example of the drawing of the curve. So we saw the mean is right here at 23.6. So that's 23.6, right? My standard deviation is 3.1. I was looking for this k value because this shaded area represents 95% of the area under the curve. What is k? K is going to be 23.8, right? And you look, that looks to be approximately maybe 2 standard deviations above the mean, right? Approximately, right? Not exact, but and that's a fairly close answer to what we were looking for. So there's 28.7. So let's try another one. How about this? This one is, now we're going to look at z-scores. So we're now looking at a standard normal distribution such that the probability of z being greater than 0.73. So now remember, for this curve is going to be a little bit different. So we're still going to use the same thing, we'll put the numbers in and we'll get the curve here in a second. So let's go to second distribution, and I'm going to go to number 3, which is my inverse normal. So for my area, because it says greater than 0.73, remember, I can only do less than on the calculator. So I'm going to say probability of z is less than or equal to k is going to be, remember, we subtract it from 1. So I'm going to say 0.27, right? So it's less than or equal to. So for my area, I'm looking at 0.27 here. Now, what is my mean and my standard deviation? Because these are z-scores, my mean is 0 and my standard deviation is 1, right? So we're looking at the z values. So we're looking at what value of k, or what is k in terms of the z-scores that are at the bottom of my graph here. So now I'm going to put in 0.27 in my calculator with a mean of 0 and a standard deviation of 1, again, because I'm dealing with the standard normal distribution, or a z-score in this case, and I press enter, and I get that k is approximately equal to negative 0.613. Rounding to the nearest thousandth there. And if we look at the graph for that, here it is down here. Remember 0, so 73% is above. We did 27% below, right? But 73% above this value. And we know that this is my mean right here at 0. So k is going to be a negative number. And in this case, it's negative 0.613, because everything to the left of the mean on our z-scores are negative values. All right, let's try one more example. And this case, this is a great one. We have a university professor determines that no more than 80% of this year's history candidates should pass the final examination. So it's one of those real pain in the ass history professors where only 80% are going to pass. So they take the exam. The exam is normally distributed, and it looks like there's a mean of 62 and a standard deviation of 13, right? So we want to find what's the lowest score necessary to pass, because only 80% are going to actually pass here, right? So we want, we're looking at this normal distribution. 80% are going to pass. So we're going to say that P, back to a pencil here. We're going to do the probability some x such that is greater than some value k is going to be 80%. Well, again, we can't do 80. We can't do greater than 80. So what are we going to do? We're going to look for the probability that x is less than some value k that is going to be equal to 20%, or 0.2. So let's plug this into our calculator. What's our area? Our area is going to be 0.2, right? And let me go second distribution, number 3, inverse normal. So I got 0.2 for my area. And then what's my mean? My mean is 62, and my standard deviation is 13. So 62, standard deviation of 13, paste, and I plug that in, and I get that k is approximately equal to 51.059. So assuming we round to the nearest number, the nearest whole number, we say that the minimum pass mark is going to be 52, whatever, I don't know, 52 out of 100 or whatever it happens to be, but only 80% are going to pass. So that means if you scored a 52 or lower, then you did not pass. You were in the bottom 20%. And that's how we use the inverse norm function on the calculator in order to find a particular k value that exists on this x-axis, whether we're talking about a normal distribution or a standard normal distribution. So whether we're looking for an x value, particular value of the actual values, or if we're looking for a z-score. Either way, we're going to use that inverse, inverse normal function on our calculator. And that's it for section D1. So check out these few problems here in 24D1, numbers 1a and b, 2a and b, and number 6. Please make sure, again, use a calculator. And if you look at the online normal distribution calculator, the only thing different now when you use this function is that you're actually going to put in the area, and it's going to give you the standard score z. So you're going to leave the top box blank, and it's going to give you the second box, as opposed to before you were putting in or it's going to give you the top box. You were putting in a different box before. So that should work for you. If you've got any questions, please let me know. Feel free to post on the discussion boards or drop me an email. And again, don't forget to turn in your assignment on eCampus as well. Hope you're doing well, and I'll talk to you next time. Take care.